Let's look at section 4.2, Irrational Numbers, example problems. Example number 1. Tell whether each number is rational or irrational. Explain how you know. We have to remember what rational means. Rational means that we can write it as a fraction of integers. Irrational means that we cannot do that. So let's take a look at our first one, the square root of 49 over 16. Well, here's an operation that we can do. We can rewrite this as the square root of 49 divided by the square root of 16. Now, the square root of 49 and the square root of 16 are both integer numbers. The square root of 49 is 7. The square root of 16 is 4. So the square root of 49 over 16 is equal to 7 divided by 4. 7 divided by 4 is a fraction of integers. Therefore, the square root of 49 over 16 is an element of the rational numbers. All right, let's take a look at the cube root of negative 30. The cube root of negative 30, well, let's take a look at our perfect cubes. Our perfect cubes are 1, 8, 27, 64. Now, the cube root of our perfect cubes are integers. The cube root of any other number is going to be irrational. So the cube root of 8, is equal to 2. That is an integer. The cube root of 9 is not a rational number. The cube root of any number other than our perfect cubes is going to be irrational, with some small exceptions for when we work with decimals. But our perfect cubes extend to the negatives as well. So for the cube root of negative 30, this is going to be approximately negative 3.1 or 2, right? Because that's our decimal approximation, and that is going to be an irrational number because it is not a perfect cube. So the cube root of negative 30 is an element of our irrational numbers, as the cube root as negative 30 is not in our list of perfect cubes. All right, now let's take a look at 1.21. Now, this number here is a terminating decimal. A terminating decimal means that it is an element of the rational numbers. We can rewrite 1.21 as a fraction. 121 divided by 100. And that is a fraction of integers. 121 is an integer, 100 is an integer, and a fraction of integers means that it is going to be a rational number. All right, let's take a look at example number 2. Use a number line to order these numbers from least to greatest, so from smallest to largest. Okay. Now, some of these are easy to compare, and some of these are difficult to compare. So it's easy to compare. The square root of 2 is definitely less than the square root of 11. That's easy to compare because they have the same index. Likewise, the cube root of negative 2 is definitely less than the cube root of 6. That's easy to compare as well. But what about the fourth root of 30? Whew. Well, that's much more difficult to compare with the rest of these. Well, first off, we know that this one here, the cube root of negative 2, is going to be the smallest. because the cube root of -2 is going to be a negative number, and none of the other ones here are going to be negative numbers. So we're going to put the cube root of -2 as definitely the smallest. Now let's judge which one next is going to be the smallest. Well, the cube root of 6 or the square root of 2 could be the smallest one. The next smallest one. So the square root of 2 is approximately 1.41. The cube root of 6, well, if I'm just looking at my list of perfect cubes, 1, then 8, boy, these are my perfect cubes. 6 goes between these two, and it is closer to 8 than 1. So the cube root of 1 is equal to 1. And the cube root of 8 is equal to 2. So the cube root of 6 has to be between 1 and 2. And I think because it's closer to the 8, it's going to be closer to 2. I'm going to guess 1.6. Now, I can't guess accurately enough to tell for sure. So I'm going to have to go to a calculator and do a decimal approximation. It's actually 1.8. 1.82. So we know that the square root 2 is smaller than the cube root of 6. Right, now the square root of 11 and the fourth root of 30. Well, the square root of 11 is going to have to be bigger than 3 because 3 squared is 9, but less than 4. I'm going to guess the square root of 11. I'm going to estimate it to be 3.2. Let's just check that on our calculator to see. 3.32. It's actually 3.32. So the square root of 11 is definitely much bigger. And the fourth root of 30. The fourth root of 30, an approximation. So here's my perfect quartix. 1, then 16, then 81. This is 1, this is 2. So 30 is between 16 and 81. So the fourth root of 30 is going to be about 2 point something. Fourth root of 30, I'm going to guess it to be about 2 point something. Maybe 2.2. But in order to do a good comparison, I need more precision than that. So I'm going to have to use a calculator to get a decimal approximation. 2.34. All right, so we can definitely order these from least to greatest. The cube root of -2 is smallest because it's negative. Then we've got the square root of 2. Then we've got the cube root of 6. Then we have the square root of 11. And lastly, oh no, the fourth root of 30. And lastly, the square root of 11. It's very easy to compare numbers when they have the same index because you can just look at the number, the radicand, and see which radicand is larger and smaller. When they have different indices, you're going to have to look at decimal approximations in order to determine which ones are larger or smaller. All right, well, thank you for watching. And if you have any questions, put them in the comments below.